In this video, we're going to continue learning about concentrations. Previously, we learned about concentrations in consumer products, which are expressed as percentages, and we also learned about very small concentrations like ppm, ppb, and ppt. In this video, we're going to focus on molar concentration, which is more commonly used in the lab. So molar concentration refers to a concentration that uses the mole as our unit of quantity for the solute. So what molar concentration actually is defined as is the amount in moles of solute dissolved in 1 liter of solution. So it's essentially moles per liter. We call that molarity or molar concentration, or sometimes just molar. And so again, you put the moles or the number of moles of solute on top and divide that by the volume of the solution present. And so that gives you a unit of mole per liter. And so these are the formulas here. We put C is equal to N over V, where N is the number of moles and V is the volume in liters. And it has to be in liters because that's how we defined it, as moles per liter. And don't forget that if you want to go from liters to mils, you multiply by 1,000, and from mils to liters, you divide by 1,000. So that will become useful, especially in this unit here, or in this portion of the unit here, where we do have to have our volume in liters. So we're going to take a look at how to prepare what's called a standard solution. And a standard solution is essentially just a solution with a known concentration. Because when you do chemical reactions, you need to know the concentration of the solution you're dealing with. So there's 2 main ways to prepare the standard solutions. There's method 2 and method 1. Method 1 is the weighing method. Method 2 is the dilution method. And we're going to take a look at how to prepare a standard solution using the weighing method in this lesson. In a future lesson, you'll take a look at method 2, which is called dilution. So think of this as the first step to understanding molar concentrations, and this will be the next step afterwards. So let's go ahead and take a look at how to prepare a standard solution using the weighing method. In a future video, we'll take a look at the dilution method. So when you're preparing a standard solution using the weighing method, first of all, you would have a target molarity. So for example, you might want to prepare a solution that's 2 moles per liter of a certain solute. So you do some fancy calculations. I'll teach you that later on. You would figure out how many grams of your solute you would need, and you would transfer the solute to a special type of flask over here called a volumetric flask. You wouldn't want to use a beaker because it's not very precise. It has a lot more error. This gives you precision. You get precision to 2 decimal places, to basically hundredths of a milliliter with the volumetric flask. So you pour in your solute. You can initially have your solute on in a beaker if you'd like, and then pour it in to the volumetric flask using a funnel. And then afterwards, what you do is you add your water. We use distilled water, so it doesn't have any other ions or anything in there. And you add your water. And your goal is to reach this line over here, because this line tells you when you have to stop adding water. But what you do is first you add the water about halfway so that you can swirl it around a bit to dissolve the solute. Once the solute is fully dissolved, then you can continue adding water up to the etched line over here. And that's when you know that you're done adding water. And you could shake a little bit more after you've stopped it all, and then you can transfer it to other containers for storage. But the whole point is that you weigh out or mass out your solute, pour the solute in, add water halfway, shake to dissolve, continue adding water up to the etched line over here, and then shake a bit more once you're done that, and your solution's ready to go. You usually store it in other types of flasks or containers. But again, the whole point is that you need to use a volumetric flask, which is more precise for volume. You need to be precise with your when you're making solutions, because otherwise it throws off the chemistry that you expect. And the cool thing about these volumetric flasks is that they have a prescribed volume to them. So for example, you might have a 50 milliliter volumetric flask or a 100 milliliter volumetric flask. So you choose the one that corresponds with the amount you want to make. So for example, if I want to make a 100 milliliter solution, I would choose one that says 100 milliliters on it, and then fill that up to the 100 milliliter line. So you can't just take your solute and then weigh, measure 100 milliliters in the graduated cylinder and add it to that. Because remember that your solution overall has to be 100 mils. Your solute takes space as well. So that's why you grab one of these and you fill up up until the line which indicates you've reached your volume required. And then that volume is essentially the volume of your water and your solute as well, taking up some space in that solution overall. So that's called the weighing method. And we're going to learn, how do you use that formula of C is equal to N over V to figure out how much of this you need, and then, how much water you'll need, so on and so forth. So that's what that formula is going to let us know. So to understand how to prepare solutions using this weighing method, and this, we prepared a standard solution, so we would know the concentration of this. So again, I went over the some of the tools you need to prepare standard solutions, but let's go over this one more time. So this here is a volumetric flask, and you would basically fill up to this line here with distilled water, and that would mean that you have your 10 milliliter solution once everything's dissolved, of course. Something else that we use, that you'll be using, especially when it comes to the second method, the dilution method, is called a volumetric pipette. And so this measures out precise volumes of liquids, and they're also marked on them in terms of how much you want to take. So this is a 10 milliliter one. This here's a 10 milliliter volumetric flask. This is a 10 milliliter volumetric pipette. They have different numbers depending on how much you need. Now, an important thing, though, is reading your measurements when you're reading your water level and knowing when to stop. Remember, we talked about how water curves. So when you fill up this flask, you need to make sure that the bottom of the curvature hits that line. So if we go over here, water, because of its polarity and sticking to the sides of glass, will form a little curvature like this over here. And so what's going to happen is when you're trying to measure when your water should stop, that little bottom of the curvature needs to hit that line. That's when you know you're done adding water. And that line there is called a meniscus. So this is called a meniscus. And if you click over here, there's some activities and a video on how to read a meniscus. So I do want you to watch that, so you can get experience reading a meniscus, especially when you go back to do some real hands-on labs in person at some point. You'll need to know how to read a meniscus. So get some practice. For example, if I were to read this volume over here, this is 50, this is 60, so 51, 52, 53, 54, 55. It looks like it's somewhere in between the 54 and the 55. So I might say, for example, 54.9. That could be it, or 54.8, but it looks like about 54.9 that I could say there, for example. Okay. And then here it might be, and then here you can also do a little reading here. So so here's 19, 20, 21. Notice the meniscus, you're reading from the bottom of the meniscus here. Okay. So we're probably around that 20 mark. So for example, here we have 19 to go all the way to 20. So here we're not going up by 1 anymore. We have 19.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, and then 20. So we could say 20.0, for example. 20.0 might work out. The other thing to know when you're reading the water level is it has to be from eye level. So you can't just stand up and look down or raise it all the way up and look up. You need to make sure that either you kneel down or it's on a high enough surface, on a flat surface, so that you're reading the meniscus from eye level. Otherwise, it throws off what your reading is going to be. Here, your reading will be, here you're just looking from too high. Here, you're looking from too low. So the correct reading method is from eye level. So do watch this little tutorial on how to do that. Reading water levels, because that's something you're going to have to do when we do more experiments with these types of equipment. So here we can see a few different tools. So again, if you click on here, there's a bit of a reading video that goes over measuring the volume of water from the meniscus. So do go over that video again to get some more practice. These are a whole bunch of different tools. The ones that we're going to focus on in this unit are going to be the volumetric flask, the burette, the volumetric pipette, and also a little bit of the graduated cylinder here. And understand that they measure to different precisions. We've kind of seen that already before. A beaker, for example, you'll have 2 sig figs, graduated cylinder, 3 sig figs, and then burette, 4 sig figs over here, but we look at the decimal places specifically. So our beaker will not give us, a decimal place. It's just our whole number there. And so it's plus or minus 1 mil. That's a lot of error. Whereas if we look at, let's say, for example, a graduated cylinder, we can go to 1 decimal place here. And it's plus or minus 0.1, so a little bit less error. And then if we look at a burette gives us 2 decimal places. So plus or minus 0.01 milliliters, which is even less error, so more precision for the burette, for example. So here we can see the steps to produce or to make a standard solution using the weighing method from solids. So basically take the solid, put it into your flask, or weigh it first, put it into your flask, add the water until it's halfway filled and dissolve, then add the water to the line until the bottom of the meniscus reaches the line. And then you can shake. And I do recommend you watch this video over here that shows you how to prepare that standard solution using the weighing methods from solids. Understand the technique that's used, understand the materials that are used, that we use distilled water, and understand that meniscus idea. Click on these links again to see videos to understand what a meniscus is and how meniscus works and to read from them. So treat this almost like a lab tutorial that you're working towards. And so what we're going to do is, in the next video, we're going to take a look at some sample problems relating to preparing solutions using the standard method that we discussed. So let me go ahead and let's go fill in some blanks together. So we are looking at, again, concentration. We're looking at molar concentrations this time. The idea of concentration is still the same. It's your solute per volume of solution. But this time we're focusing on the molar concentration. And the molar concentration is the amount of moles of solute. So the amount of, it should say solute here, in moles, dissolved in 1 liter of solution. So to calculate your molarity or molar concentration, do number of moles over volume of solution, but it has to be in liters. And so our main equation is C is equal to N over V, but you can rearrange this. So for example, you can find the number of moles by doing N is equal to C times V, or you could find the volume by doing N over C. So you can rearrange that equation, and sometimes you do need to do that. So there are 2 methods to prepare what's called standard solutions, which is just a solution of known concentration. There's method 1, which is the weighing method from a solid, and then method 2, which is the dilution method. The dilution method we'll see in a later lesson, but we use this formula over here, whereas the weighing method, we would have to use this formula here, and we'll see how to do that in some examples that we do in the next video. So there is a great demonstration to watch over here for how to prepare a solution, and I highly recommend you do that. And I also recommend you watch how to read levels from a meniscus. So you can see there's a bit of a video here along with some practice over here to learn how to read those, to learn how to read properly from these different tools. Go over what the different tools are, like the volumetric flask and also the balance that you see there. So these are our main steps. We saw weigh the appropriate mass of solute required using our balance. That was our step 1. Add the solute to a special type of flask called the volumetric flask, which gives you a very precise, a more accurate and precise volume. Add distilled water to the volumetric flask until the round bottom is basically half filled. So this round bottom part here until it's half filled. Swirl the mixture until all of it's dissolved. So all the solutes dissolved. And then continue to add distilled water until the bottom of the meniscus, that curvature of the water, reaches the etched line. So the line over here. And that's when you know that you have your 100 mils of solution or 50 mils or whatever it was that you chose for your volumetric flask. Now, generally, what we do is when you're filling up to the etched line, it fills up a bit slowly in the bottom here. And then as soon as you get to the neck here, it starts to rise faster. So what we'll often do is we'll tell you to just grab a little pipette and add, let's say you reach this point here, we'll say add the water drop-wise until you get up to the meniscus, because you do want to be as precise and accurate as possible when you're making your solution so you have the correct concentration. Once you've actually reached that point, you can just cap it, put a cap on it, and you can swirl and shake and invert to shake as well. And then you know you have your solution made, and you can transfer it into another container for storage, or you can use it immediately as needed. So we're going to do some sample problems to show you how to make a solution in this method using calculations. So I could be in a lab and I could say I need a 2 molar solution of sodium chloride. Go make it for me. So I'll show you the calculations that you need to do that, and we'll also practice doing some sketching to show what it would look like in the lab.